Okay, so we're going to work through some problems off of Module 2 and just to make sure everybody kind of has a good feel for what Module 2 is all about. So let's start off with some absolute value equations, and then we'll do some absolute value inequalities as well. So if we have something like this, um, 2 plus 2 times 3x plus 7 equals negative 2. Oops, let's see, is that? I don't want to do that one first after I looked at what that was. Well, yeah, I think I'm going to change it. I'm sorry. Let me do it. We'll do this one in just a minute, but I don't want it to be our first one. So, and you'll see why when we work through it. Okay, so let's try this one instead. If we have, this is a good one to look at. So if we have 1/2 times the absolute value of x plus 7 and then equals 2. So when we're solving absolute values, we need to get the absolute value part by itself first. And so on this one, we need to get rid of that 1/2. So to undo multiplying by 1/2, we're going to times both sides by that reciprocal. So the reciprocal, you flip that fraction upside down, and that will be 2. So we'll times both sides by 2. And when we do that here, this divides out because this is like 2 over 1, right? And so that divides out, is no longer there. So now we have the absolute value of x plus 7 equals 4. And then at this point, you need to make two equations. So whenever we're dealing with absolute value, you've got to make these two different statements. Okay, so one of them is going to be exactly the same, just without the absolute value bar. So x plus 7 equals 4. And then the other one is going to be x plus 7 equals negative 4. Right? So we need one as a positive and one as a negative is the only thing we're changing there. And then we're just going to solve this for x. So I'll subtract the 7 over and get x equals negative 3. And here when I subtract the 7 over, I get x equals negative 11. So my answers on this are negative 3 or negative 11. Right. All right, so let's go back to that one that I was talking about doing though. And I'm going to put it kind of right here next to it, because I do want you to see kind of what happens on something like this. So if I have 2 plus 2 times the absolute value of 3x plus 7 equals negative 2. So again, we still need to get that absolute value part by itself. Right? So we're undoing the order of operations. So that means we need to start by subtracting this 2 over first. And so then that's going to give me 2 times the absolute value of 3x plus 7 equals negative 2 plus another negative 2 is negative 4. And then this is connected by multiplication. Right? So to undo that, I'm going to divide both sides by 2. And so these 2's divide out. Oops, that didn't really work very good. All right, and then that leaves me with the absolute value of 3x plus 7 equals negative 4 divided by 2 gives me a negative 2. Okay, and I'm going to pause here for a second because we could set and, just make our two different equations like we did before on the other one. However, this one is a little bit different because we start off with this -2, right? Equals a -2. Well, our definition of absolute value is the distance away from 0 on the number line. And so a distance can't ever be negative. And so this is actually kind of nonsensical. It doesn't make any sense. We can't say we're going to take the absolute value of something and have it equal a negative number. So for example, if I took the absolute value of 3, I get 3 for my answer. And if I take the absolute value of -3, I get +3, right? So whenever I take the absolute value, I'm always having a positive answer. But here it's saying my answer is going to be negative. And so right at this point, I could just say that the solution does not exist. So on your homework, you would just put something like that, D and E. Now you could work out both of these. You would get 2 answers, but when you go in and try and check those answers, they're not going to work out because again, whenever you take the absolute value of a number, all right, this side is always going to be positive. I take the absolute value of that, and a positive number cannot equal a negative number. So just be careful on that. Sometimes that is can be kind of tricky on these. Okay. Do you have any questions so far on those two?
No, this is making a lot of sense. Thank you.
Yeah. Okay, let's look at an absolute value inequality also, because those are important to look at also. Okay, so here is another one. So if we have something like, ask us to solve absolute value of 3x plus 2 is less than 5. Okay. And so that less than symbol is the only thing that's kind of different from the last ones that we did. And so a way that I tell my students to help them remember, if this is an and or an or statement, because whenever we have like inequalities, it's going to be an and or an or statement. And so when you have like a less than, let's see, I'm going to put it in a different color. If you have less than or equal to, I want you to think of less than, right? Because so it's an and statement, meaning that we're looking for the overlap, right? Just like we did before when you talked about like compound inequalities. And if it's a greater than or equal to, then I want you to think of this as greater, right? So it's just kind of a play on words here, greater. And that is, we want the union of those two, like we were talking about previously in this class. Okay, so the absolute value part over here is already by itself. And if it wasn't, we would need to do the same thing that we did on the two above to get those by themselves first. But since they are already that way, I'm going to write my 2 statements down. Again, my first one is going to be just like the one here, just without the absolute value bars. So 3x plus 2 is less than 5. And then the other one is going to be 3x plus 2. And now we need to flip that symbol. So I'm going to change that just to red, just to make sure it's clear. All right, so we're going to flip that symbol and change the sign of that. So instead of being a +5, it's now going to be a -5. Okay, so I'm just putting that red in there just to make sure it stands out that you're going to flip the inequality and change the sign there. And then we'll just solve it like we normally have. So let's do that here. We'll subtract 2 over first. 3x is less than 3. And then we'll divide both sides by 3. So x is less than 1. And then here, subtract the 2 over, get 3x is greater than -7, and then we'll divide by 3. So x is greater than -7/3. Okay. Do you want to mute unless you're talking? It might help.
Oh,
just
sorry,
since we're
I
recording.
didn't know you could hear.
Yeah, no, that's okay. All right. And then on this, we will just make a graph so that we can see what we're talking about here. And I'm going to graph these in 2 different colors just to help us point out what's what. So let's see. Let's put like -2, -1, 0, 1, 2, and so on, right? So just something in there. And so if we have this, so this -7/3 is really the same thing as well, 3 divides into 7 2 times with 1 left over. So it's -2 1/3. So, and I'm just saying that changing it to a mixed number is going to be easier to draw it on your number line to know where that's at. Okay, so I'll just graph this one first since we were talking about it. So we're saying x is greater than -2 1/3. And so I'm just going to say that's kind of here, right? And then it's everything greater than it. So everything to the right. And then on our other one, x is less than 1. Whoops, and I put a closed circle there, but it should be open, right? Because it doesn't have the equal to parts. Let me see if I can redo that here. And I probably should just put in there somewhere that that is really where my -7/3 is, right? Okay, so open circle there, and then everything to the right. The other one, x is less than 1, open circle here, and everything smaller than it, so everything to the left. And then the part that they overlap, because that's what we're looking at here, right? So I go back up here to this one, and I'm like, oh, okay, this is a less than, so it's an and statement. And if it's an and statement, we're looking for the overlap. And so the overlaps between -7/3 and 1. So when we write that in interval notation, we'll have parenthesis, -7/3, comma 1, parenthesis. And that would be your answer on there. Do you have any questions on that one before I move on to the next one?
No, this is really nice. This is really good. Thank you.
You're so welcome. Okay, let's see. Let's try one like this, because this one, oops. Okay, so let's solve. Absolute value of x minus 8 is greater than or equal to -8. So remember when I said with the absolute value with the equations, we can't have it equaling a negative number, but with inequalities, that's not true because we could have a solution on this. So we are going to make our 2 statements and graph it and see what happens. All right, so here we get this as x minus 8 is greater than or equal to -8. And then on this one, x minus 8, I need to flip that inequality sign, so less than or equal to, and now I'm changing it to a +8. I'm going to put that little plus sign there just to show that specifically it is a +8. I changed it from the negative to the positive. All right, you don't have to have that there. That's just a notation to make sure it's clear. All right, and then if we solve these, right here, to get x by itself, I need to add 8 to both sides. So I get x is greater than or equal to 0. And here when I add 8 over, I get x is less than or equal to 16. Okay, and then again, since it's an inequality, we need to look at this statement right here and decide if that's an and or an or statement. Well, it's a greater than symbol. So remember I said think of greater, right? Does that play on words to help you remember that we're dealing with an or statement? So in this, we want everywhere those two graphs show up. So I'll do this one in blue and this one in green, and let's just graph it and see where those are at. Okay, so I've got, I'll put 0 here and then 16 somewhere down here. I'm not going to write all of the numbers in between there, but and so again, if I graph this one, x is greater than or equal to 0. So at 0, it has the equal to part, so I'm going to do a closed circle there. And then everything greater than it would be everything to the right. And now I'll graph the other one in green. X is less than or equal to 16. So I've got, again, a closed circle there, and then everything to the left. Okay, but remember, this is an or statement, right? If it was an and statement, we'd want the stuff in between, just like we did on the previous problem. But that's not true on here. We don't want where it overlaps. We want everywhere the green graph occurs and everywhere the blue graph occurs. So this green graph is going out to negative infinity. All right. And then the blue graph is going out to positive infinity. So that's the way we'd write our answer there. So basically, between the green graph and the blue graph, everything on the number line is going to be covered. So that means all real numbers are our solutions on this. Okay, so sometimes that can happen. Sometimes you might end up with a no solution. You know, say that you had something like that you graphed. I'm just going to make up, something here, but say that I had something like this, and then it wanted to know where the overlap is. It was an and statement. Well, these guys don't overlap anywhere. So that would end up being a no solution if we had something like that. So if it was an and statement, it would be no solution. Okay, questions there?
So anytime I get a question that is greater than a negative number, would it always end up being all real numbers?
Yeah, so let's look at that. So if I take a look at this, I'm going to write this down here again. So x minus, absolute value of x minus 8 is greater than or equal to negative 8. So remember we said when we take the absolute value of something, it's always going to end up being positive, right? So we'll end up with a positive being greater than or equal to, well, that negative 8 is always going to be negative, all right? So we're saying a positive is always greater than a negative. Is that true?
Yeah.
When is it true? It's always, right?
Always true.
Yeah, it's always true. So yeah, so thinking of it this way, right? Like you were saying, if I have this greater than symbol and then a negative 8, you're correct. It's always going to be this all real numbers.
Okay. And then, for when it says less than or equal to a negative number, that can never be true. So it would always be no solution if it was like a less than symbol.
Yeah, so on this same one, if we had something where we had a positive is less than or equal to a negative, right? Is a positive ever less than a negative?
No.
No. So that's when we'd have a no solution, when we had something like that. So yeah, so if this sign was flipped the other way, right, then we'd have a no solution in that case.
Okay, thank you.
Yeah, but be careful, because if you have something like this where it was like absolute value of x plus 5 is greater than, we'll just say 3, right? Well, here we have, that's going to be a positive number. You know, we're saying a positive number is greater than a positive number. Well, that's not always true, right? So that's where we got to determine, you know, where the overlap is and stuff. So it's only when we have like those negatives on that one side that are kind of funky that give us a weird answer. Otherwise, you just have to kind of figure out where the overlap is, or where, you know, or where the union is of those two. So good questions. All right. Let's see here. I want to do maybe just a couple more here. Let's try this one. This tends to be sometimes something that students get a little stuck on, and so I want to make sure we address something like this. So this time, if we have something that says solve, and we've got the absolute value of 4x minus 3 equals the absolute value of 7x plus 4. All right. So on this one, it's kind of different, because we've got that, you know, an absolute value equals another absolute value. And so remember, with absolute values, we don't know, you know, whether it starts off positive or negative, because they always end up being positive. They always have positive answers to them. So on this one, when we are solving it, right, we don't have anything to get by itself. And they're not going to ever have anything next to it. It'll just always be like this, where it's an absolute value equals another absolute value. But it's the setting up of the two equations that sometimes throws people off. So again, the first one is just the same without the absolute value. So 4x minus 3 equals 7x plus 4. And then on the other one, I'm going to leave the left side the same. So 4x minus 3 equals, but now we need to change this whole right side to a negative. So it's kind of like I'm distributing a negative 1 through on that 7x plus 4. So really I have here 4x minus 3 equals negative 7 times, or negative 1 times 7x is negative 7x. Negative 1 times 4 is going to give us negative 4. So what I'm trying to point out here is that both of those signs change when you have this, and oftentimes students will change the first, you know, the first term, its sign, but forget to change the sign of that second term. Right? And then from there you'll just solve it like we've done before. So, and another thing, these aren't absolute value, but whenever you have an absolute value, it's actually best to try and get the x on the left side when you're solving it, just because then you're going to be reading the absolute value backwards. But with equations, it doesn't really matter which way you go, since they're equal. All right, so I got negative 3x equals 7.
Wait, so you mean the inequalities?
Yeah, so up here, like when I'm solving inequalities, right? I always want to have the x on the left side of the inequality. Otherwise, you're reading that inequality backwards. And it's not wrong to do it that way, but oftentimes students just get a weird answer when they do that and maybe write it down wrong when they're writing the interval notation. So just be careful with them. Okay, so we got x equals negative 7/3, and then on this one, I mean, oftentimes I like to just move my x's to the left side unless it looks like it's going to be a lot easier to move them the other way. All right, so here I have 11x equals -1, and so then I'll divide by 11, so x equals -1/11. So these would be my two solutions on that. Okay, and always, always, always with absolute values, all right, absolute value equations, I should get two answers. Okay, keep that in mind. I'm kind of put that over here. Should have two answers. Okay, because we're looking at the positive case and then the negative case, so that's why we are going to end up that way.
Before we move on,
Yeah.
can I finish solving these?
Solving which ones?
I'm still like copying down what you have written.
Uh-huh. Yeah, we can pause it. Go ahead. Okay, one of the story problems that tends to show up a lot on the, quizzes and exams and stuff is one like this. Jen scored a 75, 72, and an 83 on her first 3 exams. She needs an average of 80 to earn a B in the class. What does she need to score on the 4th exam to get a B in the class? Okay, so this is a really good one. Like I said, it shows up a lot of times in the on the quizzes and the exam. So when we're thinking about this, right, we're talking about an average. And remember, an average is where you add all the numbers together and then divide by how many there are. Well, we know what she scored on the first 3 exams, but we don't know what she scored on the last exam, or, because she hasn't taken it yet. So we're going to let x equal her score of the 4th exam. And so when I write this up, all right, so an average, you add all of the numbers together and then divide by how many there are. So we're saying, okay, we got to take 75 plus 72 plus 83, but then we also need to put plus x here because we've got to add all 4 of these test scores together, and then we'll divide by 4, and that will give us the average of what she's getting on her exams. And we need it to be, she needs at least a B in the class, right? So so she needs an 80% or better on it to earn a B, right? So if we have this, we're saying, okay, it needs to be greater than or equal to 80 in order for her to pass the class. So we'll write this as an inequality, right? And then we just need to solve this for x. So first thing that we need to get rid of is this dividing by 4. So the opposite of dividing by 4 is timesing both sides by 4. And so here on the left side, those 4s divide out, right? And now I need to add these 3 together here. So I need to add my 75 plus my 72 plus my 83, and that's going to give me 230 when I add those together. So I'll have here 230 plus x is greater than or equal to 80 times 4. Well, 8 times 4 is 32, and then we need to put a 0 at the end because that was an 80. And then the last thing to do to get x by itself is just subtract 230 from both sides. All right, and so when I do that, I get 90. So she needs to score at least a 90 on that exam. And remember, with questions that are like story problems should always have like, story answers, or word problems should have word answers. So when I write this out, I want to write what this means out to the side. So I'm just going to say she needs to score 90 or better on fourth exam. All right, just to make sense of what it is that we just found there. Okay, so that's a good one to make sure that you're always looking over. That's always a good story problem there. So, okay, well, I think I'm gonna stop that here, that recording, and I hope that was helpful.